Hi, everybody. Martin Hevesy back with another episode of Cellular and Wireless Unmasked. Today, I wanted to talk about signal measurements in cellular systems. What are the common metrics? What do they mean? How is walk testing different from drive testing? And today, we'll talk about RSRP, SINR, RSRQ, and PCI, what these mean, why you should care. I do a lot of walk testing and signal measurements for my clients, and oftentimes I have to explain it over and over again. I thought, let's make a video. We can kind of walk through it once, show you some examples of good plots of RSRP, RSRQ, SINR, what that looks like, what a dominant PCI map looks like, what a good one looks like, we'll look at all kinds of examples today. Let's jump into it, and we'll start with RSRP. Okay, so we're going to start with RSRP, reference signal received power. This is the most common metric you'll see when you look at cellular testing. How strong is my signal? For most systems, RSRP is very important. It's kind of that break point and that threshold that you'll see on a walk test to say, yes, this meets the design requirements. Most of the time when you hear people talk about neg 95 over 95% of a building, they're talking about RSRP. They want to see a minimum signal level of neg 95 dBm, it's power measurement, over 95% of the building. So that's very common. So neg 95 and closer to zero, so neg 95, neg 90, neg 85, neg 80. As you get closer to zero, that's a stronger signal. As you get higher and higher, it gets worse, away from zero. So it'd be lower and lower technically. If you're neg 105 or better in an LTE system, you're going to be fine. It's a little bit more sensitive when you get to 5G. You're going to see about a 10 dB metric, a little bit better. So for an LTE system, neg 95 is fine. For a 5G system, you're going to want to see about neg 90, maybe neg 85 dBm for a 5G system. This would be for 4G, and this will be for 5G. RSRP, again, it's that main power measurement from your serving cell. How strong is it? How good is my signal? It's the reference signal. So it's not the entire piece of the spectrum. That's RSSI, Received Signal Strength Indicator. And that includes noise and other junk you don't want. So that can be very misleading if you have a lot of co-channel interference or other noise. So in LTE and 5G, we look at RSRP. That's your main measurement for power. Again, neg 95 or better is where you want to be. For 5G, you want to be 5 to 10 dB stronger, neg 90, neg 85. The range of good and bad. So if you are, again, neg 95 to neg 105, that's kind of at the edge of the system. Neg 85, neg 95 is good. Neg 75, that's smoking. Neg 65, wow, you are close to your serving cell. You're close to an antenna at neg 65, that's very strong. Neg 75, excellent. Neg 85 is good. Neg 95 is okay. Neg 105 and above, you're starting to get kind of problematic, where your data speeds are going to be low and your audio might be suffering. So let's take a look at SINR next. Okay, SINR. Very simply, SINR is the quality of your signal. It is the signal, the ratio to interference and noise. So SINR, signal to interference and noise ratio. You have your signal, interference plus noise. That is your SINR. It is a ratio of the signal you want to the stuff you don't. Any interference from co-channel or neighboring cell sites, and noise. Everything out there makes RF noise. There's all kinds of FM transmitters, AM transmitters, cordless airplanes, anything that transmits a signal, ham towers, that creates background noise and noise floor. So this ratio, SINR, is the ratio of what you want to what you don't. Very simple, that's what it is. SINR ranges from 0 to 30 dB. Okay, best you'll see, 30. If you're 30, perfectly clean signal, you're right up against the site, your RSRP is probably very good, but you can have low RSRP indicating a weak signal, but if it's clean, your SINR will be good. Now, you can also have very strong, very low, neg 65, neg 75 RSRP, and bad SINR if there's a lot of interference. But because this is a ratio, if you're in a situation where you have neg 95, neg 105, but your SINR is poor, you're close to zero SINR, you can turn your power up, you can increase the numerator of the ratio and do better. However, if there is interference and noise, it's better to weed that out. That will cause you more problems in the long run. So if you are dealing with a poor SINR condition, it's better to clean it up than try and beat it up with power. So that's a little bit of a brute engineering tactic. Better to clean it up than try to smash it with power. But if you don't know where it's coming from and you have the ability to turn up your power, that might be something that's going to help you improve your SINR. Zero is good. Zero is kind of the baseline for SINR. If you're between 0 and 5 dB, fair. You know, if your SINR is negative, that's poor, that's terrible. It's going to cause you data speed problems, bad audio, drop calls. If you're 5 to 10, that's not bad. I would call that okay SINR. You're okay, you're still positive, it's single digits, but you want to be better than 10. So for good SINR, it's 10 plus, right? So 10 to 20, if you're in the 20s, if you have a 22 SINR, that's excellent. That's really good. If you're in a building with great isolation from the macro networks, you have a radio signal powering your DAS, this is what's going to be critical to your system performance, SINR, and if you're above 10, you're in really good shape. If you're in the single digit range, you want to keep it above 5. In some downtown environments, if you're hunting for an off-air signal, you may not be able to do better than 5. Do the best you can. It's really hard in some of those congested downtown areas with lots of macros and lots of small cells. Try to keep that in the double digits, 10 plus. If it's 10 plus, you're going to have a good wireless experience. Now, when you are signal hunting, when you are looking for a donor site, if you have two options, one that's neg 95 dBm RSRP, but the SINR is 2. If you have a neg 100, but the SINR is 10, go with the 10. So if you're doing an off-air system, it's more important to have a clean channel than a strong channel. As long as you meet the minimum thresholds for good service, neg 100 is okay. That better SINR is going to do you better on your network. But just remember, RSRP is that measure of your power coming in, and SINR, signal to interference and noise ratio, is how clean is it? How good is that signal? SINR is also used as CINR, carrier to interference and noise ratio. SINR versus SINR, same metric, same quality applies. 0 to 5 is fair, 5 to 10 is okay, 10 to 15 is good, anything above 15 is excellent. You're in good shape. That's SINR. Let's take a look at RSRQ. Okay, RSRQ, reference signal, received quality. This is another metric that tells you how clean, how good is my signal to my mobile device, to whatever handset I'm using. We talked about RSRP, reference signal received power. How strong is my signal? We talked about SINR, how clean is it, how interference free is it, or interference laden is my signal. RSRQ tells you how strong is that link from your mobile device, your phone, your tablet, whatever it is, to the local cell. That could be a macro tower with macro antennas on top, broadcasting. How good is that link? RSRQ. It's measured in dB. How strong is your connection from your mobile device to the tower, to the DAS, whatever serving cell there is. The scale is between 0 dBm and about neg 20. That's what you're going to see in the real world. Lower is better. You're going to be happier if you're closer to 0. If you're closer to 20, you're going to be sad. You're not going to have a good time. What you commonly see in plots is around neg 8, neg 9 for a good signal. You know, if you have a neg 8 RSRQ, that's good. That's good quality link. That's going to give you good service. If you're neg 15 RSRQ, that's not too great. If you're neg 18, that's poor. You want to be, again, neg 10 down to 0. You want to get in the single digits for your RSRQ. You want to be neg 4, neg 5. Those are great links back to your serving cell. Again, whether it's a DAS or a macro site, doesn't matter. That's the quality of the link, RSRQ. 0 is the best. Neg 20 is bad. So anywhere in that scale, if you're in the neg teens, fair. If you're between 15 and 20, that's not good. If you're between neg 10 and neg 15, that's okay. If you're between neg 5 and neg 10, that's great. And if you're below 5, that's awesome. So reference signal, receive quality, that is, again, how good is that link from your device to the tower or DAS. The last thing I want to talk to you about is PCI physical channel identifier, and that is next. So PCI, you'll see on walk test or drive test data, PCI, physical channel identifier. It's usually a 2 or 3 digit number, 485, 281. PCI is important because if you are creating a DAS on a building, and if you're using an off-air signal, and there's a specific tower that you want to use for your donor signal, that tower has a PCI that is broadcasting at a frequency. And if you're looking for that tower, that frequency, you want to know if your PCI is correct coming into the DAS. You want to know if your channel identifier matches. If you're using, let's say, a radio signal inside the building to generate signal into your DAS, and that radio is putting out a PCI of, say, 261, and you're doing your walk testing, you want to see that PCI 261. If you have multiple zones in a large hospital or stadium DAS, an airport DAS, and you have the operators, your mobile operators, AT&T, Verizon, T-Mobile, if they're all giving you multiple radios, they all have a specific PCI, goes into a specific zone. You want to make sure everything's plumbed right. You'll go out into the field with your measuring device and you'll look for specific PCIs per the zone matrix. So if their sector 5 goes to zone 12 and it's PCI 485, you want to see 485 in that zone. So PCI lets you do that. When you're doing walk testing and you produce walk test maps, what you'll see a lot on a floor plan is you'll see a dominant PCI plot, right? Dominant PCI, meaning what is the most prevalent PCI on this floor? If you don't have a DAS and your service is poor, because you've got a lot of different cell sites, you're in a downtown area, you will see many different colors, and I'll show you an example of what that looks like. All the different channels coming in, it'll usually break down in the legend. All the different PCIs are percentage of data points. Your dominant PCI in a system with a good DAS or good coverage will be all one color, all one PCI. If you're 95, 98% better on dominant PCI, if there's one PCI, let's say again, your radio is 485, and you do your dominant PCI plot, and 98.6% of all the data points is your PCI 485, that's good. You want to be that. You might see a couple of PCIs come in at the fringe by the windows, but if your DAS is designed and built right, and you are fully dominant over the macro networks, then this will be 100%. And that's your goal, to get as much dominance from the PCI you've created with the radio or you've pulled from a donor site. Physical channel identifier. I'll show you a plot of a floor without a DAS, and you'll see lots of PCIs coming in, and you'll have one for every operator and every frequency, because a lot of all the operators use multiple frequencies these days. You'll see, AT&T 700, 850, 1900, 2100, 2300. You'll see a lot of different plots, each floor, each frequency, each operator. So when you look at a walk test package, there's a lot in it, because you'll have your RSRP per operator, per frequency, per floor. When you're reviewing walk test data, it's a lot of pages. There's a lot in it. Drive testing is what the operators do for their macro sites to measure their footprint and confirm that it's built right and it's plumbed right. That's drive testing. In a building, you do walk testing. You usually carry a scanning receiver or some other type of measuring device. And when you're walking through the building, you have to physically stop every 5 feet or so and touch the map to tell the system where you're at. When you drive test, you've got GPS, you've got good signal, you can see to the sky, to the satellites, you know where it's at when it collects data. For walk testing, you have to physically touch the map and tell it to collect RSRP, referenced signal receive power, SINR, signal to interference and noise ratio, RSRQ, reference signal receive quality, or your PCI maps. That's your physical channel identifier. Is the right signal in the right place? Let me show you what some good maps and some poor maps look like for each metric. For PCI, there is no good or bad. You want to be at this dBi. It's not, or dBm. It's not really about that. It's about dominance. Do I have the PCI I want through the majority of my covered area? That's what I want to see. So here are some good and bad plots of RSRP, RSRQ, SINR, and dominant PCI. Neg 80 is really good. If you have neg 65, neg 75, that's smoking signal. Good between neg 80, neg 90, neg 95, that's good. Fair 95 to 105, 90 to 105, that's fair. Anything above neg 105 or worse than neg 105, you have neg 110 RSRP, that's not very good signal. That's not really going to link to your phone very well. So you want to keep it at neg 105 or better. You want it to be, for a walk test, usually neg 95 across 95% of your covered target area. For RSRQ, reference signal receive quality, again, you want to be as close to neg 20, as close to 0 as you can, away from neg 20. Neg 20 is bad. You don't want to be anywhere near neg 20. That is poor. You don't want that. You want it to be below neg 10. You want that neg 8. You want that neg 6. You want that neg 4. Those are strong, good links to your serving cell. Between neg 10 and neg 15, that's okay. That's going to give you a decent link. You know, neg 15 and neg 20 is going to work. It's not great. It's fair, but it's going to work. Neg 16, it's not great, but you're in the ballpark. Your phone, your link is going to be okay. Your data speeds are probably going to be slow. If you get into the neg 10 to neg 15 or better than neg 10, you're going to get much better data speeds on that channel. And again, if you are neg 18, neg 19, neg 20, neg 21, that's really poor. You're going to have a bad time at that RSRQ. For SINR, again, that ratio of signal to interference and noise, you're looking for positive. Number one, if it's negative, it is bad. It's below poor. Anything below 0 is bad. SINR from 1 to 10 is fair. 5 or 6 SINR, that's okay. That's in that fair range. It's going to work. It's going to work okay. You'll have okay audio quality. If you're good SINR, if you're 10 or above, you're going to be great. It's 10 or above is okay, especially if you're signal hunting for a good donor. 10, 15, 16 SINR, that's good. That's really good. If you can get your SINR into the above 20 range, 22, 25, 26, if you can do that, that's excellent. Usually in a properly designed DAS with not a lot of zones that cause competing interference, your SINR is going to be very strong. If you hold up your phone right up to a radio and there's no other RF in the area, you will get very close. If not 30, you will get close to 30. So I will show you what a good SINR plot looks like. But here's your matrix. I can link this to the video down below in the comments. RSRP, RSRQ, SINR, they all tell you a little bit different metric as to how good your signal is. Talked about dominant PCI, physical channel identifier, why that's important. When your DAS is done, you want to see dominance from the channel that you're boosting on the target area, in that floor, in that area. Before the DAS, you will see a lot of different PCIs coming in, a lot of different colors on the plot. When it's dominant, you'll see one color. The majority of those data points will be that one PCI you want. RSRP, strong signal. RSRQ, how good is my link to the serving Cellular DAS, and SINR, how clean is my channel. I hope this has been helpful. Thank you so much for watching. It always helps when you subscribe and share with others. Have a great day.